Day 9, Weather Forecasting Using Historical Data. So let's build this weather forecasting model using historical data, where in this project we'll predict the temperature or weather conditions using historical weather data. We'll use linear regression for this simple prediction task. So let's get started. So first, I am going to start a new file. I'll save it as today is day9.py, and we'll initially start with importing the necessary libraries. The libraries that we need in this particular case is, first, let's get pandas, which is used for handling the data set. So I'm going to say pandas as PD. Next, I need the train test split from the sklearn model selection, which splits the data set into training and test sets. So I'm going to say from sklearn dot model selection import train test split. And next, I'll get the linear regression from sklearn linear model, which implements the linear regression model for weather forecasting. So I am going to say from sklearn dot linear model import linear regression. Next, I would need the mean square error and R2 score used to evaluate the performance of the model. This I can get from sklearn dot metrics. I'll say import mean squared error and R2 score. Next, I will need, let's import matplotlib dot pyplot as plt. This is used to visualize the actual and predicted temperatures. So let's get started. So first thing that we want to do is probably get the sample historical weather data set. So for that, I have some data which I will just copy paste inside this. I'll just paste it here, where I have here, as you can see, I have the days, which is 1 to 10. I have temperature for these days from 30 degrees to 31 degrees and everything in between, up and down, humidity, wind speed, precipitation, and next day temperature. So I have this data set that I'm going to use, and I am going to say df equal to pd, I'll use pandas, and create a data frame with the data that I have. So in the first step, this is a small data set with features like temperature, humidity, wind speed, and precipitation, along with the next day's temperature as the target. That's what I have. You can replace this with a real data set from sources like Weather API. Next, we are converting the dictionary into pandas data frame, calling the data frame function inside pandas. Now, next step is feature and target variable. So let's go and create the features, which is the features that I'm interested right now are, I am going to say I am interested in temperature, I am interested in humidity, I am interested in wind, where is my speed, wind speed, and I am interested in the last one, which is the precipitation. So these are the features that I'm interested in. Next, the target, y equal to data frame, and in this case I am just interested in the next day temperature. Perfect. So that's my target. So x is the independent variable, which are called features, that include temperature, humidity, wind speed, and precipitation for a particular day, and y is the dependent variable, which is the next day's temperature. So now let's split the data set using the train test split, which splits the data set into 80% for training and 20% for testing, and also will give a random state for it, which is one second, x train, which is the number 42. X underscore test, y underscore train, and y underscore test. Now this I can get from train test split, pass it x, y, I'll give the test size equal to 0.2, and I'll give the random state equal to 42. So next step is training the linear regression model. For that, I'll just say model equal to, this goes with linear regression model. This initializes the linear regression model. Next, I will fit, I'll say model dot fit and pass x underscore train and y underscore train. So this trains the model using the training data x underscore train and y underscore train. Now let's next step in our process is to making predictions. So let's go and make the predictions. I'll save it in y underscore pred. I'll say model dot predict and pass it x underscore test data that I have to check our prediction. So this uses the trained model to predict the next day's temperature for the test set. Now finally, let's evaluate the model. So for evaluating, we have imported two things. One is mean square error and R2 score. So for that, I'll say MSE equal to mean square error, pass it y underscore test and y underscore pred, R2 equal to R2 underscore score, pass y underscore test and y underscore pred. So the first one, again, the mean square error calculates the mean square error, which measures the average square difference between the actual and the predicted temperatures. A lower MSE indicates better performance, whereas R2 calculates the R2 score, which indicates how well the model fits the data. And R2 score closer to 1 means better performance. So they're a little bit different. So now let's start with, now if I want to see, let's visualize the data. For that, we know what to use, the plot from matplotlib. I am going to say I want to create a figure, and that is of the size, fig size, I can say equal to 10, width and height 6. So next, let's plot the x and so the test and the predicted, the actual temperatures and predicted temperatures. So for that, I'll say plt dot plot and pass it first y underscore test dot values, and I'll give a label which says actual temperatures, and I'll give a marker equal to O. Okay, next I'll do the same thing for predicted values, which I will say y underscore pred values. Instead of actual, I'll say predicted, and marker instead of O, I'll use X, so it's easy to see the difference. Next, let's give them titles also. Plot dot title, I am going to say actual versus predicted temperatures. So again, now we have the first line which plots the actual temperatures from the test set. Second one plots the predicted temperatures from the model. I have given a title. Next, let's say dot x label, x label, and this label will be, we'll call it test sample index. Next, let's use the y label and give this one as temperature. Next, I am going to plt dot legend. What this does is this adds a legend to differentiate between actual and predicted values. And then finally, I'll say show. So this will show my, displays the plot. Now, if I want to predict, let's move it down. Now, if I want to predict temperature for new data, I can pass a new data object. Let's create a new data variable. I'll say pd dot data frame, and to that I want to give, let's make sure everything's perfect. First is temperature. Now temperature, let's say around 30. Next, I want to give humidity. This is more like, let's say today is, this is the weather that we have. Humidity of 60, pretty high. I want to say the wind speed today is around 10 miles per hour. I'll say precipitation is around, let's say no precipitation today, 0. Now I want to predict tomorrow's temperatures. So for that, I'll say predicted underscore temperature equal to model dot predicted or predict and pass this new data element to it, and then I will print, let's say f, and I'll give some new lines so it's spaced out properly, and I'll say predicted temperature for the next day is this. Let's copy this thing. Predicted temperature at the element 0, and I want it as 0.2 F, and I'll say this is in Celsius because we have given all the other temperatures in Celsius. So we'll print it out. We'll get the predicted value also in temperature. So let's save it. And now I'll go open this and say Python day9.py. It's going to run through that thing and first show us the plot. Oh, I said ypred dot values here, which is wrong. I just need the y predicted value because that's only one value here. So go back, clear it out, run it again, and there you go. We have our actual temperatures versus predicted temperatures. Here it says test sample index, temperature, actual versus, so our plot is here. Also, if I close this here, it will give me predicted temperature based on today's temperature. Tomorrow it's predicting that it will be 31.7 degrees Celsius. So that's the prediction for tomorrow. So we have completed our day 9 where we created a weather forecasting using historical data. If you have any questions, let me know and I'll get back to you.